Alright, hey everyone. So in the second video that talks about rational expressions, we're going to go through a lot of examples here. I would almost encourage maybe pause the video and you can fast forward through it and kind of jotting down each different example and give it a try as you go. You could also pause the video as I get to a problem and try it out. And then kind of unpause the video when you're stuck or when you think you have a solution for it. And then we'll kind of progress through like that, because I think I'm just going to kind of run through the examples. There's, like I say, there's a bunch altogether here. So as you kind of get to a question, you can try it out, or you could just kind of skip ahead and try out a few problems and see how you go. But I would encourage that you kind of go through and try all of the questions that are here, just to see if you have that handle on your factoring skills, as well as trying to come up with these non-permissible values are. So to start to run through this, let's start to go through example 1. So in this case, we need to simplify and state the restrictions on the following expressions. So in each one of these, what we're going to do is we're going to begin by factoring that expression. So first we have x squared minus 9, and then we have x squared minus x minus 6. So our top one is a binomial term, and they're both squares, so that's a perfect square, so that's a difference of squares question. I have x plus 3 and x minus 3. And then all of that is going to be over. And then now on the bottom I have a trinomial term, and it's a type A one, so I'm trying to think what two things can multiply to give me negative 6, and those same two numbers can add to give me negative 1. And so again, if you had a chance to kind of maybe go through this, or if you're just using this one as the example, two things that multiply to make negative 6 and have a difference of 1, so 3 and 2, and the negative is going to have to go with the larger number because it's a negative x, so x minus 3 and x plus 2. Now from here, I can see, okay, x cannot equal 3 or negative 2, because if x equals 3 here, I'm going to get 0, and I can't have that. If x is negative 2 here, I'm going to get 0, and I can't have that. Now, the other part that we can do is we can start to eliminate terms that have common factors. So I have an x minus 3 in both of them, so I'm going to cross out my x minus 3 terms, and then I have x plus 3 over x plus 2. That is my final answer with my non-permissible values that x can't be 3 and negative 2. And then you might say, okay, well, why is 3 a non-permissible value if it's not even part of the final solution? I should be able to work through this from start to finish, get the same answer every time, so the same answer from the start right out to the end. And so because of that, anywhere through my solution where I can have something that will equal 0 in the denominator spot, I have to write that down as a restriction. Even if it's, say, in the second step, if I identify a non-permissible value, I need to write it down, because any of these steps should be able to be used to either graph the function or to evaluate the function at a certain term or at a certain value. So if I were to plug like 1 in for x, it should work in all three of those steps to give me the same answer. Which means that each of these values are going to be equally important. So let's go on and try the second one. So in our second one, we need to simplify again and state our restrictions. So like I mentioned before, maybe you want to pause the video and try out each question as I get to it, or maybe you want to skip ahead and try out a bunch of them and just kind of see me run through the answers for them, just to check off and make sure you're on the right track. So for the first one, the numerator spot, we take a look and see what we can factor out here. It looks like I can factor out a 3x squared term, so 3x squared. And then what's left over? Well, 3 times 1 is 3, and looks like I'm going to have an x there. 3 times 1 is 3, and then x squared times x is x cubed. Minus, and then I have a 3x squared and a 3x squared, so times 1. And then on the bottom, it looks like I can factor out an x squared, and I'm going to be left with that x minus 1 again. Now I can see right away where this is kind of going, that x cannot equal, in the first one, x cannot be 0, and over here, x cannot equal 1. So there's my restrictions. But then I see that x minus 1 can cancel, so I've got 3x squared over x squared. And then my x squareds can actually cancel, and so really I can evaluate this thing right down to 3 as a final answer. But really, x cannot be 0 or 1. Okay, because remember, I should be able to evaluate it at any spot. The next one, if I evaluate the top expression here, I'm looking for 2 things that multiply to make 5 and add to make 6. So x plus 5 and x plus 1, where 5 times 1 make 5, 5 plus 1 is 6, all over on top of x plus 1. That shows that x cannot equal 1, or sorry, negative 1. And then these are going to cancel, and it looks like I'm going to get an answer, or a simplified version, that is x plus 5, where we have the idea that x cannot equal negative 1. So again, just evaluating the term, simplifying it down, and then stating the restrictions that are on it, or those non-permissible values. In my next one, y squared minus 16, notice it's a binomial term and they're both perfect squares. So y minus 4 and y plus 4 over, now 2 things that multiply to make negative 32, and those same 2 things add to make 4. So I have a difference here, right? Negative 32. So that means that when I start this off, it's a type A, so I know I can open up my 2 brackets. I know I'm going to have y at the beginning of each one. My larger term is going to be positive, and it's 8 and 4. So y plus 8, y minus 4. 8 times 4 is negative 32. 8 times negative 4. 8 minus 4 is positive 4. So again, I have my values here. Looks like y plus 8 cannot equal 0, so it looks like y can't equal negative 8. And the same thing, y minus 4 can't equal 0, which means it looks like y cannot equal positive 4. So y minus 4, they can cancel out, and I'm going to get a value that's y plus 4 over y plus 8, with the idea that y cannot equal negative 8, and it can't equal positive 4. Okay, simplified version and my restrictions. Next example, when I look at this one now, this is a binomial term as well, but I don't have any perfect squares here. So this looks like a common factoring kind of question. If I look at the 10 and the 15, it looks like I can take out a 5. If I look at the a and the a squared, it means I can take out an a, and a b, so I can take out a b. And then when I write what's left over, 5 times something gives me 10, so 5 times 2. A times nothing is, or a times 1 I guess is a, but I don't need the 1, and same with the b. Minus 5 times 3, give me 15, and then a times a would give me a squared, so I have a there, and then the b is already there. If I look at the bottom now, between 12 and 8, looks like a 4 can come out, as well as an a term. And so here, 4 times 3 would give me 12, and then a times a is a squared. Minus 4 times 2 would give me my 8, and I already have an a. I can see right away that my restrictions here, for a cannot equal 0, which means that a can't equal 0. And then on this side, 3a minus 2 cannot equal 0. 3a can't equal 2. Move the 2 over to the other side, becomes positive, which means that a can't equal 2 over 3. Now, in terms of simplifying this, I can see that the a's are going to cancel. Now, what I don't see right away, that's not as clear as what's in here. I do have a 2, and I do have a 3a. So the only thing that's different with this is the signs are different. So if I were to factor a negative 1 out of here, basically divide each term by negative 1, we can start to see what's going to happen. If I factor out a negative, I'm going to take out a negative. So negative 5b, remember I canceled out the a. Negative 5b, so I took out a negative. I divided each term by -1. I'm going to get -2 plus 3a. Right? If I take a negative times a negative, it gives me my positive back again. Negative times a positive gives me my negative back again. So I didn't change anything here. I just factored out a -1. And then I have a 4 and 3a minus 2. Now if I rewrite the top part, negative 5b, and then put the positive term first, now I have 3a minus 2 on the top, which works out well because on the bottom I also have 3a minus 2, and they can cancel out. So really this thing evaluates at the end to minus 5b over 4, with the idea that a cannot equal 0, and it can't equal 2/3. Example 6. So this one looks like I have these type 2 trinomials, so they're going to start to get a little bit trickier. Here I have a coefficient different than 1 in the front. So in that case, remember, two things that multiply to make, and then I have to do the a times the c term. Two things that multiply to make -30, and those same two things are going to add on the top here to make positive 13. And it looks like right away I can see 10 and 3 are going to be my combination here. So if I had 10 and 3 here, two things that multiply to make -30. Actually, 10 and 3 won't work here because I can't have anything work out to be my negative, so I need something else. 15 and 2. And then I can see that 15 and 2 will work because I'll have 15 and -2. One had to be a positive and one had to be a negative. That's the reason why the 10 and the 3 didn't work. So 15 and -2. So I'm just going to work out the top part for right now and kind of doodle that out, and then we'll take a look at the second part after that. So just the numerator, 3x squared plus 15x minus 2x, I wrote out my two coefficient answers in place of the 13, minus 10. Group your first two terms together and your last two terms together. Factor out a 3 and an x. Looks like I'm going to have x plus 5 left over. And on this one I'm going to factor out a -2, and that's going to make x plus 5. Now I have a common x plus 5 in each one, so I'm going to factor that out, x plus 5, and then my other one is 3x minus 2. So this is my top part over here, right? So really this breaks apart into x plus 5 and 3x minus 2. Okay, there's one. So now the bottom one, I'm going to have to do the same thing. What two things can multiply to make -10? And those same two things can add to make 9. So it looks like 10 and 1. Positive value is going to be my 10 because I need to get positive 9 out. So 10 and -1. And then same thing, 2x squared plus 10x minus an x minus 10. I'm going to group together my first two terms, my last two terms. Oh, I wrote a 10 there. Sorry, that should be a 5. So, first thing I'm going to factor out is a 2x, and I'm going to get x plus 5. And then here I've got minus x minus 5, so I'm going to take out a minus out of that. And then I'm going to rewrite that as x plus 5. Right? Negative times x is negative x. Negative 1 times 5 is negative 5. Because x plus 5 isn't common, I've got x plus 5 and 2x minus 1. So now way up here, now I have x plus 5 and 2x minus 1. So I can see from here, x cannot equal -5. And then I can see over here, 2x minus 1 cannot equal 0, so 2x cannot equal 1, which means that x cannot equal 1/2. So I have my restrictions. I also can take a look at this and see I've got an x plus 5 in common out of each one that can cancel. So as a final answer, I'm going to have 3x minus 2 over 2x minus 1. I'm going to tuck them in brackets. They don't need to be, but I'm going to put them in brackets and say that x cannot equal negative 5 or 1/2. So that one had some type 2 trinomial questions in it. It's a little bit longer, but still doable to go through as long as we take it step by step. Okay, so our next one. Here we have a regular polynomial on the top. So I have something times something to make 12, and add to make negative 7. Looks like it's going to be 2 of the same sign, 4 and 3. And that's all over. Now it looks like I can factor out an x term to start with. And then I'm going to have x to the 4 minus 81. So that just happens to be a double perfect square. X minus 4, x minus 3. Now I have a binomial term here. You see how 4 is a perfect square and 81 is a perfect square? X squared plus 9, x squared minus 9. And then one more go at it, because now I realize that I have perfect squares again. So x squared plus 9, and then x plus 3, and x minus 3, right? The double perfect square. Now, I can see that I have a whole bunch of different restrictions that could be here. Looks like there's more than there actually is. X can't be negative 3 or positive 3, and that actually works out here as well, because this really doesn't do anything. Because regardless if I have a negative or a positive here, I'm going to get a 9 out, and then I can't make 0 out of that. So, x cannot be 0 from the first one, or plus or minus 3. The negative 3's cancel. Looks like I have a final value or final evaluated answer. That's simplified. X minus 4 over x squared plus 9, and x plus 3. Where x cannot equal 0 plus or minus 3. 0 or plus or minus 3. All right, example 8. So we're just going to kind of keep going through here. Like I said, there's a lot of different examples to try out here just to practice factoring. So 6 minus 2m, what are we looking for here? We're looking for a common factor. It's a binomial, but they're not perfect squares. Looks like I can take out a 2. And then I'll have a 3 minus m left over. And then on the bottom, I do have a binomial that is perfect squares. M plus 3, m minus 3. We did this problem a couple of questions ago. You see how this is really similar to this one? If I divide each of these by negative 1, essentially I'm going to factor out a negative. Okay, negative 2. I'm going to factor out that negative. I can rewrite this as negative 3 plus m. Right, and I really haven't changed anything in the question because I should be able to go from here back to here. Negative times negative 3 is positive 3. A negative times positive m is negative m. And then all I'm going to do is just rewrite my positive value first and my number second. And then I have m plus 3 and m minus 3. So I can see here that m cannot equal negative 3, and I can see here that m cannot equal positive 3. These are going to cancel, and negative 2 over m plus 3 is going to be my solution, where m cannot equal plus or minus 3. All right, almost there. So consider our expression here. It says what expression represents the non-permissible value for x. Simplify it, evaluate the expression, and it gives us a couple of different parts and show 2 ways to determine the answer. So with this one, we need to start off and go through our simplifying step first. So let's do the same thing we've been doing the whole way through so far. So let's start off. We have 16x squared minus 9y squared. All of those, it's a binomial term, and all of them are perfect squares. So really I could rewrite this as 4x plus 3y, 4x minus 3y. Do you see how when we multiply this out, 4x times 4x is 16x squared. 4x minus 3y minus 12xy plus 12xy, your inside terms cancel out, and then minus 9y squared for the last term when you FOIL it. Okay, binomial term, all perfect squares, just a plus and a minus. Now I've got 8x minus 6y. It looks like out of this I can take out a 2. And then I have a 4x minus 3y. So I can see that these cancel out. And I have 4x plus 3y over 2 as my final value. Now, my non-permissible value here, 4x minus 3y can't equal 0, which means that 4x can't equal 3y, which means that x cannot equal 3y over 4. So, my solution, and then my non-permissible value that x can't be 3y over 4. So, evaluate the expression what expression represents the non-permissible value for x. So, non-permissible values, the expression 3y over 4. X can't be 3y over 4, so here's really my A. Simplify it, here's my B. Now my C is really saying, let's take our expressions, evaluate the expression for this and this, show 2 ways to determine your answer. So I could start with my beginning and my end. That's 2 different ways, and I should get the same answer as long as I'm on the right track here. So let's start off with 2.6. 16 times 2.6 squared minus 9 times 1.2 squared. Remember, y is 1.2, x is 2.6. 8 times 2.6 minus 6 times 1.2. So all I'm going to do is just simplify this expression. So 2.6 squared gives us 6.76. So 16 times 6.76 minus, and then I'll have a 9 and 1.2 squared. 1.2 times 1.2, 1.44. And then on the bottom, I've got 8 times 2.6, that's 20.8. And then I have 6 times 1.2, so that's 7.2. And then 16 times 6.76 gives me 108.16 minus 9 times 1.44 is 12.96 over, and then we have 20.8 minus 7.2 is 13.6, and then the last one we'll just do is one step here. So 108.16 subtract 12.96, sorry, 108.16 subtract 12.96 gives us 95.2. We're going to divide that by 13.6, and it works out to 7. Now, that is if I started off with my original equation. But what if I start off with my solution at the end? 4 times 2.6 plus 3 times 1.2 all over 2. So 4 times 2.6 is 10.4, plus 3.6, 3 times 1.2. If I add those two together, so over 2, add 10.4 and 3.6, I'm going to get 14. Over 2, I'm going to get 7. So regardless, two different ways just kind of verifies for me that I have the right simplified expression, because I'm getting the same answer for both. So that was a lot of different examples to go through. Now I've got one other one here that's a little bit of a challenge because it looks complicated to start with and gives you a little bit to work with. And so we want to go through and identify this in those non-permissible terms again. So if you haven't already, pause the video, give it a try, and come back when you're ready. Alright, so if we started off, I could square this first term, x plus 2 times x plus 2. If I do that, I get x squared plus 4x plus 4. That's the first term. Minus an x, minus 2, and then minus 20. Okay, so square this one out, and then just expand the brackets, and you get the top part. Then I'm going to combine like terms together. 4x minus an x is 3x. 4 minus 20 minus 2 more is minus 18. Once I get this, I can see that I have 6 times 3 is going to give me negative 18. It's a positive 3, so I need a positive 6. Then I can see that my negative 3 terms are going to cancel out. X plus 6, x plus 3, and x can't be minus 3 or plus 3 as my answer. So a lot of different questions. There are some practice problems to go through in the textbook as well. And that's kind of where our next assignment's going to lead to. So good luck, and if you have any questions, let me know.